Hi students, let's discuss about the desirable properties of routing algorithm. We have 6 properties. First one and second one are correctness and simplicity, and it's very clear from the name itself. What is correctness? If we choose a routing algorithm, the packet should be forwarded to the destination from the source without any error. Okay, that shows the correctness of algorithm. Simplicity means the algorithm should be very simple, and there should not be any overhead for the hardware or software for implementing that algorithm. Simplicity. That's what simplicity is. Now, coming to the third one, robustness and stability. They are very hard to achieve. Okay, those two properties. What is robustness? If you consider a network, there can be any software or hardware failures. There can be any software or hardware failures. Whatever happens, the routing algorithm should be able to route the packet to the destination. If a router on the path from source to destination is failed, routing algorithm should be able to reroute the packet so that it correctly reaches the destination. So, robustness explains it. Okay. The algorithm should be able to detect any change in the topology or network traffic or any hardware software failures. Okay, it is not possible to reboot the network because of a hardware or software failure. Okay, so the routing algorithm should work without any problem and route the packet to the destination. And coming to stability, how stable the algorithm is for any conditions of the network. Okay, then coming to the fifth and sixth property, fairness and optimality. They are conflicting properties. If we try to achieve fairness, optimality we have to compromise. Okay, what is fairness? Every node should get fair chance of transmission. What is optimality? Optimality always carry towards minimum or maximum. A packet should reach the destination in minimum time. The throughput should be maximum. So optimality always followed by two words. Okay. So if we need optimal transmission between A and A dash, okay, minimum time it should take for a packet to route from A to A dash means we can put a restriction like there should not be any traffic between these 2 points. But we are violating the fairness policy of X. So then X won't be able to route its packet to the destination X dash or C. So if you try to achieve optimality, fairness is violated. So these two policies are two conflicting one. Okay. Now coming to optimality principle. So we have 3 nodes. One is I, J, and K. Okay. Distance between I to J is D1. Distance between J to K is D2. So total distance is D1 plus D2. So this is the optimal path from I to K through J. What does mean? Optimal means here optimal means minimal path, minimum distance path. Okay, so if there is any transmission from J to K, okay, we can see that from J to K there is another path, the distance is T3. So if there is an optimal path from I to K through J, all the traffic from J to K also should follow the same path. So all traffic from J to K also follows this path instead of this one. Okay, that is what optimality principle says. And set of all optimal route from source to the destination gives a set sync tree. We will see an example here. This is we have a network here. For example, from L, from L, this is the optimal path. Okay, so we can say that all traffic from K, F, and A to B also follows the same path. So this is not part of the network, so we don't need this part. Okay, so if we consider, if we draw all the optimal path from some nodes to the destination B, here B is the destination, we will get a tree like this, and this tree is called a sync tree. Sync tree. See this. Here this shows all the optimal route from D, G, H, L, K, F, A, and E, I, J, N, O, M to the destination. So that's all about the desirable properties of routing algorithm. Thank you for listening.